Hey everybody, welcome to our overview of Desmos for the math section of the SAT. The Desmos Graphing Calculator is a powerful tool embedded in both sections of the math SAT, which can be used for many features and functions that can make solving math questions much simpler. Now, obviously, Desmos is a tool. Ultimately, we do need to understand the underlying math concepts that we're being tested on so that we can apply Desmos in different ways to try to solve them or check our answers, etc. But that being said, Desmos still makes our lives a lot easier, and it's in our best interest to know how to use it very well. Desmos has a keyboard down at the bottom that can give us access to some of our quick reaches that we need to be able to input. For example, if we want to do x squared times 5, we could do that here. There's a couple of functions. We see our trig functions there, sine, inverse trig, some of our statistics functions, and then a couple of symbols like less than, greater than or equal to, pi, and the square root symbol, etc. Now we can also type those directly from our keyboard. We don't need to use theirs. For example, if you type in SQRT, it gives you the square root symbol. Could be a lot quicker, right? You could just type in pi, and that's your pi symbol over there, right? Now, Desmos is a graphing calculator, and we can visualize things on Desmos. Let's say we wanted to see the graph of 3x raised to the second. Now, we can go to the keyboard and then hit that raised to the second button, or you can use the caret symbol. So you hit shift, and then for me, that's 6. It looks like a little up arrow. And then now it's an exponent 3x squared. There we go. And when we have something like this, you can see that we don't have the best view of it right now. It looks kind of skinny, right? So we can zoom in and out using these buttons over here. You can click and drag anywhere along the graph just to get the view that you want. Now, using this wrench, we can also play around with a couple of key items. For example, the axes numbers we can toggle on and off. We could even label our axes, right? So let's say X is the number of years and Y is, I don't know, the growth, right, of some type of bacterial culture or something like that, right? So we have years, growth, and if we wanted to delete those, we could obviously clear that out. Again, if it helps you with questions that have different variables than you're used to and you want to just understand what the relationship is. We can also change our axes, so the window. In this case, we notice that the parabola looks kind of skinny. If we want to see it kind of fill up the window a little bit more, we can make our negative side go up to, let's say, negative 20. So there's negative 20 over here. And then we can make this side go to 20 as well. And there's that. We could also make the y-axis. Let's make that negative 20. And let's say we wanted to see it up to y is less than or equal to 100. And there we go. We can also toggle from radians to degrees over here as well if we are being tested on trig functions. And if we ever want to just go back to the original home view, we just click that home button over there. Now, aside from graphing, Desmos can be used for mathematical functions. We can input values. So let's say we have a parabola ax squared, right? And we can use this value a, I don't know, we could assign a the value of 2, right? We could say b equals 6, right? So then let's say we have ax, and do that, to the squared plus bx, and there would be the function ax squared plus bx, where a equals 2 and b equals 6. And we could play around with the different value of b, we could play around with the different value of a, right, and see what that does to both of the functions that we have over here. And we can use those in calculations, right? If we wanted to just do a plus b, for example, that's 1.2 plus 4.1 as well. And if we ever needed to delete anything, by the way, we have 5 inputs over here. You could hit this gear and then just delete all, okay? We can also input lists. Lists are often analyzed on the SAT. Let's say we have list A equals, and then we input lists using a square bracket. So let's say we have the list 3, 8, 9, 12, 14, 18, 22, right? And let's say we wanted to find the mean or the average of this list. We just type in mean, parentheses, A, and then that pulls set A over there is 12.28. Let's say we wanted the median of A. and that ends up being 12. So we can really quickly compare the mean and median, right? Let's see what happens if we remove this value 18 from the list. And we could see how that changes the mean and median accordingly. So that's super helpful. Now, one thing to note is you don't need your list to be in order, right? Especially for the median, everything needs to be listed least to greatest. But let's say we added some smaller numbers, 3, 2, 65, and 4, right? So it still calculates our median without everything being in least to greatest, which is nice. And we could also use the stats function to find a couple of key statistics about any set, right? So over here, it finds our minimum for us, that is 2. First quartile, median, which we knew was 8.5, max is 65, etc. So that's all helpful to know. And then sliders, we touched on this before, but when we assign a value, let's say a equals 2, we also get this little feature down here, which is called a slider, and we can play around with how that impacts graphs or calculations or anything like that, right? So let's say we wanted to do a plus 2 raised to the x. And we could play around with a here, see what that does to the graph. As a goes up, the graph goes up. As a goes down, the graph goes down. We could also mess around with how much we want to be able to swing a around, right? So we could do from -20 to 20. And then you could hit this play button over here, and it'll show you what happens as a goes up and as a comes back down. So sliders are super cool for visualizing changes to functions, or you could use them to set equivalent expressions. More on that coming. I could spend all day talking about sliders. One other cool feature of Desmos is that it could be used to do calculations. 3/4, for example, equals 0.75. 3/4, 0.75. But even cooler, as we know, when we're adding fractions, we need to have common denominators, but not with Desmos. Let's say we want to add 3/4 and 5/7, so that'll quickly give you 1.46, or if we wanted to see that in fraction form, that's 41/28. So that's a useful and cool tool as well. And again, if you ever wanted to delete and clear everything out, you could use that gear button. More coming on some more of the specific tools we can use as to how we can use them on specific SAT questions, just so you get a sense of how these tools can be used to accomplish different tasks, or what type of questions we can see and how we might want to approach them in different ways.